Bismillahirrahmanirrahim. Assalamu alaikum. Today in this tutorial we will discuss different kinds of timers available in Mitsubishi PLCs, that is on delay timer, off delay timer and retentive timer. Furthermore, we will also discuss different kinds of counters available in Mitsubishi PLCs, there is up counter, down counter. So we will start right now. First of all, we will construct a program for on delay timer. On delay timer is a timer which turns something on after a special delay, after some delay. How we can create this delay? So let's begin. Before proceeding further in this video, please subscribe my channel so that you can get a notification for every new video. We will take an input with, let's suppose it is x0, and an output that will be the timer. We have different kinds of timer available in Mitsubishi PLCs, T0, T1, T2, T3 and so on. All these normal timers can be used for the on delay timer. So we will select here timer T0 space K50, and here we will use the contact of this timer T0, and we will attach an output with it, that is Y0. This is my motor Y0 and this is my timer T0 K50. K is the constant, its value is 0.1 and it multiplies with 50 and gives us 5-second delay. So first of all we will convert it, going to online and write this program to PLC. Execute. Yes, yes, yes. So this program is successfully transferred to my PLC. I will check whether it is working or not. So I am checking it in monitor mode, going to monitor mode. Here when I will press X0 on, my timer will start its timing, and when it reaches 50, then its normally open contact will be closed and this my motor will be turned on. So I start here, yes, it is working. After 50 it will turn my motor on. This is on delay timer. It delayed some special delay 5 seconds in turning on my output Y0. So it is called on delay timer in Mitsubishi PLCs. Going to write mode and we will construct here off delay timer. Off delay timer, we will take an input x1 and an output in the shape of a timer. So it will be, I will take T1 as my next timer, T1 space K50 or K30, and here we will use normal close contact of my timer T1 and some output will be attached with it. This is Y1. So this is my on delay, this is my off delay timer. It turns something off after a special delay, after some delay. As this is normally close contact, when I will write this program, this Y1 will turn on, and when I press X1, the timer T1 starts its timing, and after reaching 30 seconds, after reaching 30, it will turn this contact off and this output will be turned off. So first of all, convert this program online, write to PLC, program plus parameter, execute, yes, yes, yes. This program is loaded to my PLC memory. So I will check whether it is working or not. Going to online and monitor mode. As you can see that my motor is in running condition. It is working, and when I press this X1, it will turn on this timer, and when this timer completes its delay, it will turn this switch off and this output will be turned off. So it will provide some delay to this output to be turned off. So I am pressing X1. X1 is turned on. After 30 seconds it will be off. Yes, it is off, and now this output is turned off. So it is called off delay timer. It delays something to be turned off. That's why it is called off delay timer. The last one, these timers are non-retentive timers. On delay timers, off delay timers are non-retentive timers. You can see that when I turn this X0 or X1 turn off, these timers will be reset to its zero position. It does not retain its time. It means that these are the non-retentive timers. The other and the third timer that we will discuss now is retentive timer. Retentive timer is the timer. So delete all these lines. Delete row. I will delete line, delete line, delete line, delete line. Yes. So I will construct here a program for the retentive timer. In Mitsubishi PLCs, timers ranging from T250 to T250 to T255, a total of 6 timers are called as retentive timers. You can use the timers to retain your time. So I will take a retentive timer here. That would be, I think, T250 space K100. This is my retentive timer, and I will use its contact here. This normal open contact T250, and attach an output with this contact, that is Y2, and this is my retentive timer. Here I will use an input X1, now convert this program, online write to PLC, program plus parameter, execute, yes, yes. This program is now completed, loaded to my PLC. I will check whether it is working or not. Going to monitor mode. When I turned X1 on, write to PLC, program plus parameter, execute, yes, 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 I will check whether it is working or not. First of all, going to its write mode. For this timer, I also need a reset command to turn this timer to its zero position, to its initial position. Otherwise, it can't be turned to its zero position because it retains its time. When it starts its timing and reaches up to, let's suppose, 30, then if you turn off its input x1, then it will retain its position on 30. If you start again, it will start its timing 30, 31, 32, 33 and onward. If it is stopped at 50, it will stop its timing 50 and onward, 51, 52, 53 and so on. So for this purpose, we need an extra input to turn this timer off, x2, and an instruction command will be used, rst space t250. This command will turn this timer to its original position, that is zero position. Now convert online, write to PLC, program press parameter, execute, yes, yes, yes. Now we will check whether it is working or not in monitor mode. It is not working properly. I am checking this program again. It is T250. I will take 251. Here 251, T251 again. Here again you can change its timer. I think this is 251. Convert online, write to PLC, execute, yes, yes. Going to online, monitor mode, yes, it is working. It is working properly. When I press X1 on, the timer starts timing. When I press it off, it retains its timing position, that is 34. When I turn it on again, it starts its timing from 34, not 0. You can check it out. After 100, when it reaches to its 100 limit, this input will be turned on and this output will glow on. When you want to turn this timer off, you can't turn off it from X1. You can turn this off from this reset command, x2. Yes, when you press x2, this timer will be turned to zero position. So this timer from T250 to T255, these are the timers which are used for retentive timers in Mitsubishi PLCs. Now we will proceed further to check the counters, different counters available in Mitsubishi PLCs. First of all, I will take a counter here, C0 space K10. I will take a new program so that I can start my project from starting position. New project. Okay. No. I will take an input x0 and a counter which is taken from selecting a coil, C0 space K10. This 10 is the count of my counter. These are the normal counters. Here I will take normal open contact of this counter, and again an output will be attached with it to turn it on or off. Write to PLC. First of all, convert it online. Write to PLC. This is up counter. This is up counter available in PLC. You can see that how it is working. First of all, going to monitor mode, and I will turn X0 on. You can see that it counts 1. I'm again press X0. It counts 2, 3, 4, 5, 6, 7, 8, 9, and it when reaches its final limit, then this output, this counter contact will be closed, and this output will be in running position. Yes, you can see that when it reaches its maximum value, its contact becomes closed and output will be turned on. This is called up counter. All the counters are working as up counter in Mitsubishi PLCs. In previous tutorials I have discussed counters and timers in detail. How many counters available in normal counters position in normal counter range, and how many counters available in down counter range, retentive counters range. You can see that in the previous tutorials. Now I will make here a program for down counter. In Mitsubishi PLC FX3UC16M, we have counters from C200 to C230. Almost 32 counters are available. C200 to C230 counters. C230, these are the counters available which can work as down counter for you. For this purpose, you need a special relay to make this counter as a down counter. First of all, I will construct its program, taking X1 as input and a counter C201 space K5, and I will take here again an input X2, and a special relay will be connected with this input, which is called M8201. This number 201 is the number of the counter, this counter, and M8 is the relay number. M8 is a special relay which turns this counter as a down counter when it is in active position. When it is not in active position, deactive position, it will work as an up counter. But when we turn on this relay, then it will make this counter as a down counter. We will check it out. First of all, we need to select again an input X3 to reset this counter C201. First of all, here you need to select an instruction command for the reset. To make the counter reset, you need to select RST C201. So this is the reset command to turn the counter into its initial position. You can use this command for up counter and down counter both. I am using here for this down counter. First of all, convert this program. Going to online, write to PLC, program plus parameter, execute, yes, yes, yes. So I will check it out whether it is working or not. Going to monitor mode. This is X1. When I press X1, it will count 1, X2, 2, 3, 4 and 5. When it reaches its value 5. Now it is its maximum value. I want to make this counter count downward direction, so I need to turn this button on so that my relay make this counter, this special relay M8201 will make this counter as a down counter. So X1 will make it down counter, X2 will make it down counter. So now you can click on X1 again, you will see that it will you can see that when you turn it on off, it will count in the downward position. Yes, I am pressing X1 on and off, it is going in the downward direction. So this special relay, when turns on, it will make the counter downward counter. If you want to reset this counter C201, you need to click on X3. So this will make your counter down counter. When you want to make it as up counter, you need to turn this X2 off. So now it will work as up counter again. And you want to reset this counter, click on X3. X3 when it will reset this counter to its initial position, 0 position. So these are my counters in Mitsubishi PLCs. I hope that you may have learned something very special, something very new from this lecture, from this tutorial, and stay tuned with me for next videos and other videos which will increase your knowledge, which will upgrade your knowledge regarding Mitsubishi PLCs. Thank you so much for watching this video.